Hi there, welcome back to my channel, and in this video I'm going to take you through logarithmic functions. So when you say logarithmic functions, it falls under a category of functions called transcendental functions. Transcendental functions. So these are functions which are not algebraic, okay? So they have their own form and their own protocols. So when we say logarithmic function, generally is f of x is equal to log to the base a of what? X, okay? Now, where a is greater than 0, the base you have here should be greater than 0. Then also, our base a shouldn't be equal to 1. It should not be equal to 1, okay? So take note. For every function to be a logarithmic function, the base a should always be greater than 0 and also should not be what? 1. Okay. Yeah. So now let's see the domain and the range properties of logarithmic function. When you talk about the domain of logarithmic functions, when you say a log, okay, the argument, this we call it argument. So when I write a log to the base, let's say b, whatever I have to put in here is what I call argument. Okay, argument. So it's receiving an argument or an input. So for logarithmic functions, it takes only positive arguments. Positive arguments. So meaning for my domain, it doesn't take any negative, but it can take what? 0, right? Yes, it can take 0. So the domain generally is giving us open bracket 0 plus infinity. Okay. So meaning a set of numbers from 0 to positive infinity is the domain for all logarithmic functions. Now what about the range? For the range of logarithmic function. Now once you put this 0 to positive infinity here, a logarithmic function can give both positive and negative results. Therefore, the range is what? A set of all real numbers. A set of all real numbers. Now I have a special logarithmic function I would like to talk about, which we call the natural log length. So this is called natural logarithm. Natural logarithm. Yep. So the natural logarithm is simply our normal logarithm that you know to the base e, where e is the Euler's number. Where e is the Euler's number. Okay. This is the Euler's number which I talked about in our previous video. So log to the base e gives what we call length of what? A particular argument. So take note. Log to the base e gives what? Length. So when you see length, it means that you are dealing with what? Logarithm. It means you are dealing with logarithm. So take note of that. So if you want to draw logarithmic function, you have your axis. This, you know that logarithmic function doesn't take any negative x, so we are just interested in the positive x-axis. Okay, this is our positive y and negative y. For that reason, I will have anything like something this way. Can have something like something coming in this way, and I can have something like this way. So it can start from infinity, then it will approach towards negative infinity, and it can also start from positive infinity and also approach negative infinity in that manner. So that is simply what logarithmic function. Logarithmic functions. So you can have examples of logarithm as simply being as, let's say, log to the base 2 on 3x. Yes, you can also have something like log to the base root of 7x. They are all logarithmic functions. Okay, so take note. So this is the end of this section. Kindly subscribe, like, and share.